I've just undertaken a very quick walk around the building and around the outside of the building just to establish the types of systems that exist here. I can see from my outside observations that there are 6 separate external mounted units. Walking around the building, I've found 6 internal units, so I can be quite happy that I've initially found all of the pairs of systems within the building. Under the sampling requirements of the air conditioning survey, we would need to undertake an inspection of a minimum of 10% of the external condensers, or a minimum of 3 units, whichever is the greater. Therefore, we need to have a look at 3 of the systems within the building and look at the indoor units connected with those external condensers as well. If during the course of our inspection we find any issues or complications with the 3 condenser units that we're investigating, we will need to undertake a survey on the additional 2 units as part of the sampling requirements for the air conditioning survey. Now that we've finished the inspection part of the survey, we now need to collect some more information to undertake the estimated cooling loads calculations. For this, we need to take measurements of all the rooms in which the air conditioning systems are located in order to calculate and estimate cooling loads and compare these against the installed capacities of the systems. So here, I'm just going to take a couple of quick measurements using my laser measurer. This information should be noted on your survey notes so that you can calculate the area when you're back in the office and compare your estimated cooling loads against the rated capacity of the system in the space. After undertaking our initial walk around the inside and outside of the building, we're now moving outside to look at the external condensers in a lot more detail. This is the first system that we're going to be looking at, which is a split system which serves a first floor office space in here. Now, we've tried to get access to the refrigerant pipework at the back of this unit. Because this is bolted directly onto the outside of the building, the refrigerant pipes run from the back of the unit straight through the wall to inside. When speaking to the building manager and arranging this visit, we did talk about trying to get one of the service engineers down to remove some of these panels so we can get access to the pipework and take the temperature reading across the compressor. Unfortunately, we weren't able to organise this. With the building manager's permission, we did try and remove a small panel at the side of the unit here, which would give us access to the refrigerant pipework from the rear of the compressor. However, because of the age of the system, we were unable to get this cover off and didn't want to damage the unit. Full notes of this restriction should be noted within the survey report. There are, however, some things that we can look at while we're here. We should be making note of the model and serial numbers for the unit, which can be found on the nameplate, which is located up here. This also contains details of the refrigerant and the refrigerant charging system. This unit is filled with 410A refrigerant and was installed in 2005. Therefore, it's quite a new system. We can look generally at the condition of the condenser unit. We can see that there is a build-up of dust and dirt around the system, which is typical of it being attached to the side of the building like this and being at a high enough level so it becomes difficult to clean. There is debris beneath the unit here, which is from when they drilled through the wall to install the refrigerant pipework. It would be advisable to recommend that this is cleaned up. Otherwise, some of this debris could find its way back into the unit. We now want to go around the side to look at the condition of the condenser fins within the units. Because of the location of the unit here, these are hard up against the building and therefore restrict the airflow through the unit to take the heat away. The condenser fins themselves are actually in a very good condition, mainly because of the age of the building and because they're protected from being hard up against the building. However, the performance of the system and the amount of air which can pass through the units is greatly reduced by this location. One of the recommendations, therefore, would be to see if relocation was an option. On a practical note, we can see that there really isn't anywhere else to relocate these within close proximity to this first floor office space, and therefore this is just a limitation on the system as designed. However, it should be noted in the report that a recommendation for perhaps future installations would be to locate the condensers somewhere away from the building itself. This is another external condenser unit linked to an indoor wall-mounted unit inside. We have refrigerant pipework coming into and out of the unit here with an electrical isolator to the side. At the moment this is turned off. The unit itself is very dated, and we can see from the nameplate at the top here that it was installed in 1998. The system contains R22 refrigerant. You should write within the report that the system contains R22 refrigerant and provide details within the report for where the building manager can find more information on the phasing out of refrigerants. While we're here, we need to take temperature readings across the compressor. This involves taking our infrared thermometer and taking a temperature reading of this exposed piece of pipework here. By comparing this against the ambient air temperature and the temperature at the condenser fins, we can then have a reasonable understanding of the efficiency of the compressor. What we're going to do now is go around to the side and look at the condenser fins, and just to check for any damage within the fins themselves that could reduce the airflow through the system. There we go. We now need to take the temperature reading of the condenser fins in order to be able to calculate the temperature difference across the compressor. In this particular case, we need to take a temperature reading at the four corners, wherever possible, of the condenser fins, so that we can understand the temperature drop through the condenser coil as well. This is important because we can't get into the unit to understand in which corner the compressor output flows into first. So this is as simple as just taking our infrared temperature sensor and trying to pick up the horizontal pipework within the fins. Ideally here we're looking for a temperature of 10 to 15 degrees higher than the ambient temperature. This would indicate that the compressor is working efficiently and is increasing the temperature of the refrigerant such that we're enabling greater heat rejection to atmosphere.